Let's solve problems using congruent triangles. In item number 6, a triangle DEF is a 90-degree clockwise rotation of triangle ABC, and find FD. So from the given problem, we know that these two triangles are just congruent or equal. It's just that their orientations were or are different because of the transformation made, which is rotation by 90 degrees, which means that their corresponding parts are still congruent. Okay, we just realign or reposition its or the triangles. Okay, so the positions are just different, but again, the corresponding parts are still congruent. So here, let's identify the corresponding parts. We know that A corresponds to D, so that's AD, okay, and B corresponds to E, all right, and C corresponds to none other than F. Okay, how did we know the corresponding parts of these two triangles? Number one, you can use the shape of these two triangles. All right, so we know that the triangle's shape is like this, okay, ABC, and once it is rotated, of course, the shape will still be the same, and we could identify the corresponding parts through shape. And number two, we can use the 90-degree clockwise rotation, okay? So uh, we can use this one. Now, what would be its shape or orientation if we're going to move it by 90 degrees? Of course, 90 degrees would be here, all right? So A will be turned to here. So A now becomes our D. And of course, B becomes our E, and C becomes our F. Okay, so that's how we look for or identify the corresponding parts once we transform the triangle or the shapes. So since we already identified the corresponding parts, so we know that triangle ABC is congruent to triangle DEF. Okay, and it only means that AC or segment AC is congruent to AC. AC is congruent to DF. DF. Okay, or we could say the measure of the segment AC is equal to the measure of the segment DF or FD. All right. Now, since we have measures or values for or expressions for AC and DF, then we can substitute them here. So 3x plus 18 is equal to 5x minus 22. Okay, and let's solve for x. So we have 2x is equal to, what's this? This is 40, and x is equal to 20, right? So if x is equal to 20, and we're solving for FD is equal to 5x minus 22. So our FD, all right, the measure of FD is equal to 5x minus 22, and our x is equal to 20. So this is 5 times 20 minus 22. So this becomes 100 minus 22, and this is equal to 78. Therefore, the measure of FD is equal to 78. So let's check if there's 70. Okay, here we go. So the answer is the 78. Okay, now let's go to the next item. And by the way, if you want to answer this first, then just pause the video. And once you're done, try to play the video and check if our answers are the same or equal. Okay, number 7. Which method is not universal method for proving triangles congruent? Okay, I think this one is easy. Now, let's recall the postulates and theorems we use uh, for proving that the two triangles are congruent. So we have the SSS postulates or postulate. We have the SAS postulate. We have the ASA postulate. And the last one is we have the AAS or the SAA theorem. Okay, we can use this to prove that the two triangles are congruent. So let's check. We have SSS, we have SAS, ASA, and we don't have SSA. So this is our answer because we're looking for not, okay, not a universal method for proving triangles congruent. All right. So since SSA or ASS is not part of the given postulates or theorem, then of course the answer number 7 is SSA. And I hope we have the same answer. Okay, let's move on to the next item. All right, here we go, number 8. So triangle DEF is a translation of triangle ABC. So again, there is a translation happened here. And again, when we translate the shapes and the sizes, the corresponding parts of the triangles ABC to the triangle DEF are actually equal, okay? Because we did not resize and reshape the figure. So we just move it to another point or space in the XY plane, okay? Or another region. So here, which translation maps triangle ABC onto DEF? So we need to check for, or we need to look into one point here, okay? And I know according to its shape and orientation, now they're just equal actually, and C corresponds to F, A corresponds to D, and B corresponds to E, right? So how does this point move? Okay, so let's check that here. Let's check how far it moved below. It went down, right? So triangle ABC was moved down and it became triangle DEF. So from this point is negative 3, 1. It went down to, oh, what's this? 3, 3, negative 4. So how many units down? All right, how many units down? That's 1, 2, 3, 4, 5. So that's 5 points below. Negative 5, correct? So it went down by negative 5. So we have negative 5 here. And others don't have negative 5. Okay, so it's just like we added negative 5 to 1 to get negative 4. And how about the x? How is the x or the horizontal uh, orientation of this triangle? Okay, how do we look or find for the translation based on the horizontal axis or the x-axis? So we have, so let's use another color. So we have this, right? So this is our x. We know this is negative 5. So let's count 1, 2, 3, 4, 5, 6. So that's going to the right. So it means we added 6 points. Okay, so that's why from negative 3, it became positive 3. Or we can just subtract using distance formula. 3 minus negative 3, that's positive 6. So that's positive 6. Okay, so it only means that this is the answer. Okay, the second option is the answer here. Okay, so I hope we got the same answer too. All right, now let's go to the next question, letter B. In letter B, the question here is, okay, let's move. If angle A is equal to, okay, this is angle A, is equal to 2x minus 10, 2x minus 10. Okay, angle A, measure of angle A is 2x minus 10, and angle D, measure of angle D is equal to 3x minus 52. Then how many degrees are contained in angle A? So here, angle A and angle D are being used here. So we know that angles A and D are the corresponding angles of these two triangles. And since these two triangles are congruent, we could say that angle A is congruent to angle D, or the measure of angle A is equal to the measure of angle D. So which means that 2x minus 10 is equal to 3x minus 52, right? So this is 2x. So let's solve. Let's use red. So this becomes x is equal to 42. Yeah, if I'm not mistaken. So the answer is 42. Here we go. So this is the answer in number, okay, in number 8. All right, and I hope we had got the same answer again. And let's work on item number 9. Okay, now number 9, after a series of rigid transformations, triangle DOG is mapped into triangle D prime, O prime, G prime, or the dog primes, okay? So find the value of X. All right, so on the triangle DG, okay, the segment DG corresponds to what? So we need to find for the corresponding parts for us to solve for the value of X. So based on each shape, okay, DG corresponds to DG, DG primes, okay? So DOG is mapped to DOG prime. So it means O is mapped to O, D is mapped to D prime, sorry, O is mapped to O prime, D is mapped to D prime, and G is mapped to G prime. So which means that DG, okay, let's write it down. DG is equal to, sorry, the measure, oops, the measure uh, of segment DG, oh no, is, oh, so let me change this. Okay, so the measure of the segment DG is equal to the measure of the segment D prime, G prime. All right, so what is the measure of DG? So that's 6x plus 8. And how about D prime, G prime? That's 3x plus 26. All right, because these two triangles are congruent. Again, when we translate the triangles now, or transform the triangles, we just change its orientation, but still the corresponding parts are still congruent, okay, or equal. So here we have 3x is equal to 18 and x is equal to 9. Oh, sorry, 3x. So x is equal to, oh my God, sorry. Okay, x is equal to 18 divided by 3, that's 6. This is 3, okay. Right, so the answer is 6. And here. Okay, so I hope we got the same answer. Let's proceed to the next, number 10. All right, let's solve this. If two angles and one side of one triangle are congruent, okay, so let's draw the triangle. Here, let's say ABC. Again, guys, when we talk about geometry, better to draw the figure so as we could easily determine the relationships of the parts. So if two angles in one side of the triangle are congruent to the corresponding parts of another triangle, so let's have another triangle here. So AB, A prime, B prime, and C prime. Okay, if two angles in one side of one triangle are congruent to the corresponding parts of another triangle, so there are two angles. So let's say we have angle A and C to, or C prime to C. All right, so another one is to one side of one triangle. Let's say that side is here. Okay, There we go. The triangles are blank congruent. Okay, so let's identify. Will it be always congruent, sometimes congruent, or never congruent? Now, let's say the side, the corresponding side, or the corresponding congruent side, or the congruent corresponding side of these two triangles are AB, and A prime, B prime. So can we consider this as congruent? Yes, by what reason? By AAS theorem. So this is still congruent, right? Okay, now what if the side is changed to here? Okay, let's consider this side. Let's try another case, case 2. So if these two corresponding sides are congruent, and these two corresponding angles are congruent as well, then can we say that these two triangles are congruent? Yes, by another, same thing. Okay, we can use the AAS theorem or the SAAA theorem. So therefore, it's still congruent. And another case that can be considered is this. What if this side or this corresponding congruent side, okay, happens to be here? Now, so that's angle, side angle, angle, side angle. Is it still congruent, or are they still congruent? Yes, for what reason? That's angle, side, angle postulate. So, which means, guys, that these triangles are always congruent, even if we place the corresponding congruent sides anywhere else in the triangle. Okay, so case 1, it's true by AES. Case 2, it's true by AES again. And case 3, it's true by ASA. So it's always congruent. Okay, so which means if two angles in one side of one triangle are congruent to the corresponding parts of the one of another triangle, then the triangles are also congruent. Okay, so we have proven that using cases 1, 2, and 3. Okay, I hope we got the same answer. And let's have the last item, I guess. Okay, so let's identify. It can be proven that BC and CD are congruent. So this one, BD and BC are congruent if it is known that. Okay, so we need to identify. Now, how do we do that? So for us to show that BD and BC or DC are congruent, we need to show first that these triangles, these two triangles, BAD, okay, is congruent to triangle CAD. All right, so we need to show it first for us to show that BD and DC are congruent. Okay, but how do we show that triangle BAD and triangle CAD are congruent? So let's use the given. Okay, we have already identified congruent sides, congruent corresponding sides. Okay, and also these sides are congruent. AD is congruent to AD by reflexive property. So AB is congruent to AC. All right, given. And AD is congruent to AD by reflexive property. Okay, so we have side, side. And oh, we could have another angle here. So angle BAD is congruent to angle CAD. Okay, CAD. Oh no, CAD. Okay, so this one, we're looking for these angles to be congruent for us to show that these two sides are congruent. So once we prove that these two triangles are congruent, which we have already proven to be congruent, then by CP, which means corresponding parts of congruent triangles are congruent, then BD is also congruent to DC. So that's angle BAD, and CAD is this. Okay, so we're done in number 11, and I hope we got the same answer. Oh, there is another problem here, so let's solve this. I think this is the last one. All right, quadrilateral ABCD Okay, quadrilateral ABCD. CD is congruent to quadrilateral, let's say. Since it's congruent, then they should have the same shape. So E, F, G, H. Again, AE, BF. Let's check the correspondence. CG and HD. Okay, here we go. Now, if measure of angle A, let's use another color, this one. Angle A is 6x minus 8. And angle E, this one, is 4x plus 1. Okay, find the measure of angle A. Okay, so here, we know that A corresponds to E. Therefore, these corresponding angles are congruent because these quadrilateral are congruent. So, since the measure of angle A is congruent or equal to the measure of angle E, then we know that 6x minus 8 is equal to 4x plus 1. All right, so let's solve. So this becomes 2x. 2x is equal to 9. And x is equal to 9 over 2. Okay, so x is equal to 9 over 2. And we're solving for the measure of angle A. So if x is equal to 9 over 2, so angle A, 6x minus 8. So x is equal to 9 over 2. This is 6 minus 8. So this becomes, I can cancel this out. This becomes 3. 3 times 9 is 27 minus 8. That's equal to, 19. That's equal to 19. Therefore, the measure of angle A is equal to 19. Here we go. So we have this. Okay, I hope we got the same answer. All right, and if you have some comments, let me know.